weren't in place the last time we designed a Corvette. In addition to that, we have carbon fiber being applied to the standard vehicle for the first time. So some of the structural composites that reinforce and bond onto this aluminum frame are a mix of glass and carbon and composites, and then some of the exterior panels are actually 100% carbon fiber. The hood is inner and outer carbon fiber. It only weighs about 11 pounds, the whole hood. This is kind of the holy grail carbon fibers used in aerospace, military, airplanes now, high-end bicycles. It's kind of the holy grail material, but it's terribly, terribly expensive. So we're taking a huge step, driving costs down and volumes up as a preamble to maybe using carbon fiber in a lot of different cars.
You must have had a lot of challenges with manufacturing, and you had to integrate that as well.
Sure, this frame is a new material for us to build in-house. We use the latest manufacturing techniques. There's hollow castings, there's extremely strong extrusion, 7000 series extrusions, high pressure die castings. Then we have to join them all together, and we're using laser welding, bonding, flow drilled screws. Sometimes we had to invent some techniques to bond some different kinds of materials together, but it's all to get a super light, super stiff structure that's also dimensionally perfect.
Well, I'm sure you spent some time behind the wheel. You know, how's the excitement level?
What I tell people is the car looks great, but it drives even better. Because the car is so light and so stiff, because the engine has so much low-end torque, it's super responsive. The steering system's actually 5 times the stiffness of today's car, so there's an immediacy to the car that's instantly noticeable behind the wheel. We have electronics in the differential that let the car behave extremely benignly when it needs to, but extremely responsively when you want it to as well.
When you were doing your major engineering, were you working with design as well so that you could get their design to meld with what you wanted in the vehicle?
What you see in this design is the melding of inspired design, racing technology. We essentially took lessons learned from the racetrack and incorporated them straight into the design. That's what makes the design look so interesting, is taking those racing techniques but applying them to the car in a very integrated and seamless way. Our design folks were right on board with that philosophy. We didn't want to just make the car look different for different sake. We wanted to make it look different because it needed to look different to work better as a performance car.
Some individuals have talked about you haven't really put a lot of performance into it, but you say that you have. Can you explain that a little bit, even though there's not the most horsepower in the world there?
Yeah, I think people were looking for sort of a brute force way to get more performance, just massively increase the horsepower. That's not a realistic scenario anymore, given fuel economy requirements, CO2 regulations around the world. So we were going about it in a much more sophisticated way. The aerodynamics of the design that I talked about actually make this car faster on a track than our up-level performance Grand Sport model of today, and this is available now on the standard Corvette Stingray.
Can you talk a little bit about the faster acceleration? You say that it launches very well and has better acceleration. How did you meet those criteria?
We've done a lot to move weight and rearward in the car. It's not just that the car's light, but it has a rear weight bias, so about 51% of the weight is on the rear wheels. So the tires get a lot of traction. We got new tires from Michelin that have fantastic grip. We have electronic differential. We've got an engine with a lot of low-end torque. So this car gets off the line like crazy. 0 to 60 under 4 seconds for both the manual and the automatic transmission.
Very good. Thank you. That does it well.
That was good.
Yeah.